NASA Jet Propulsion Laboratory. 1. And what it discovered didn't stop the world because it was alien. It stopped the world because it showed us something brutally simple. Space is not quiet. The edge of the sun's influence is not a clean border. And the machine we threw into the dark almost 50 years ago is still measuring a place no human has ever touched. But first, you need to feel how far away we're talking. Voyager 1 is not in deep space, the way people meme in movies. It's beyond the bubble of the solar wind, beyond the heliosphere, out in the real in-between, the space between stars. NASA calls it the asterisk asterisk. Voyager interstellar mission asterisk asterisk. And Voyager 1 has been there since 2012. NASA Science 2. So when Voyager speaks, it whispers. And the whisper takes almost a full day to reach us. By the time you hear it, it already happened yesterday. You're basically listening to a ghost voicemail from the edge of the map. Now, here's the open loop you're going to want to stick around for. In late 2023, Voyager 1 started sending garbage signals that looked like a spacecraft having a stroke. Then, in 2024 and 2025, NASA pulled off a chain of fixes that sound like science fiction. Asterisks, asterisks, they remotely bypassed damaged computer memory. Asterisks, asterisks, brought back science instruments and even revived thrusters that had been considered dead for decades. NASA Jet Propulsion Laboratory, 1. And that's where the turned back myth is born. Because when Voyager lost the ability to send clear data, it felt like we'd lost it. Then it came back. And when it came back, we didn't just get status, okay? We got a front row seat to the physics happening in interstellar space, right at the boundary where our sun's influence fades and the galaxy starts pushing back. Let's rewind to why Voyager 1 matters so much and why this isn't just nostalgia. Voyager 1 launched in 1977. JPL built it to do a planetary road trip, Jupiter and Saturn, during a rare alignment that made gravity assists possible. You've heard the phrase, once in 175 years. The key idea is real, even if the exact number gets thrown around a lot. The outer planets lined up in a way that let Voyager hop planet to planet like stepping stones. And here's the funny part. Voyager was built with less computing power than a cheap calculator today, but it was engineered with so much foresight that it's still working in 2026. That's like building a bicycle in the 1,970 seconds and riding it non-stop until your grandkids are grown in a blizzard with the chain half broken and it still somehow pedals. After Jupiter and Saturn, Voyager 1 took the upper exit ramp out of the solar system plane. It didn't go toward Uranus and Neptune like Voyager 2. It went north, above the pancake of the planets, into emptier territory. And it carried a weird little artifact of humanity with it. The golden record, sounds of Earth, greetings, music, a time capsule. People love that part. But the real treasure isn't the record. It's the instruments. Voyager 1 has been measuring the solar wind, magnetic fields, energetic particles, plasma waves, basically the invisible weather of space on a road no one has ever driven. And in 2012, it crossed into interstellar space. NASA explains that boundary like this. The heliosphere is the sun's protective bubble, solar wind, pushing outward until it meets the interstellar medium pushing inward. Voyager 1 passed through the heliopause and became the first object to directly sample that outside region. NASA Science 2. So what does outside feel like? Not empty. It's more like leaving your house during a storm and stepping into a different storm you didn't know was there. Cosmic rays change. The particle environment shifts. The plasma gets denser in ways Voyager could infer through plasma wave measurements, even after one of its direct plasma instruments failed long ago. NASA Science 2. That alone is world-class science. But now comes the problem, the part where the story goes from legendary mission to how is this thing still alive? Voyager is old. Old in a way we almost never deal with in technology. This probe has been flying so long that its parts have aged, its power has declined, and its systems are held together by careful decisions. Shutting off heaters, shutting off instruments, saving watts like you're camping with your last flashlight battery. And because it's so far, you don't get to try again quickly. You send a command. It takes nearly a day to arrive. Voyager reacts. Then the reply takes nearly a day to come back. So every big repair is slow, risky, and nerve-wracking. Then, in late 2023, Voyager 1 starts returning a weird stream of unreadable data. It's like calling your oldest relative, someone you love, and suddenly the phone line turns into pure static. But you can still hear breathing. You can tell they're there. You just can't understand a single word. NASA confirmed in April 2024 that Voyager 1 was finally sending usable engineering data again after months of this, and the fault was traced to a part of the system involved in packaging data. The solution involved asterisk, asterisk, moving code around to work around damaged memory, asterisk, asterisk. NASA Jet Propulsion Laboratory. 1. That's the first turn back. Not a turn in space, a turn in communication. A dead conversation becoming a real conversation again. And once they got the health and status data back, they pushed for science data. By mid-2024, Voyager 1 resumed returning science data from its instruments again, and NASA's Voyager blog described it as normal science operations returning after the computer issue. NASA Science 3. That's when headlines hit, because fixing a near 50-year-old spacecraft from billions of miles away is one of those rare human achievements that makes even people who don't care about space go, wait, what? But it wasn't over. Voyager doesn't just need working computers. It needs to keep its antenna pointed at Earth. That's where the thrusters come in. Voyager has tiny thrusters that keep it oriented. Over decades, they deal with wear and residue buildup, basically clogging issues that can eventually stop them from working the way they should. So JPL does careful thruster swaps, switching to backups, managing what still works, stretching the system's life. Then, in 2025, NASA described something that honestly sounds like a miracle save. Engineers asterisk asterisk revived a set of Voyager 1 thrusters, asterisk asterisk, that had been considered inoperable since 2004, because they wanted them available as backups, as other thrusters faced clogging risk. NASA Science 4. That is the second turn back. The ability to keep pointing back at Earth, keeping the link alive, just got stronger. So when people online say Voyager turned back, what they're emotionally reacting to is this. Voyager was fading, then it recovered. Voyager was losing control, then it stabilized. Voyager was going quiet, then it started talking clearly again. Now, here's the part you came for. What did Voyager 1 discover? If you were expecting aliens to control, I'm not going to sell you that fairy tale. But I times am times going to tell you something that should still give you chills, because it's real. Voyager is showing us that interstellar space is not a dead void. It's structured. It has magnetic fields that don't behave like the inside of the heliosphere. It has particle populations that are different. It has plasma waves that can ring through space like a giant invisible bell. And the edge of the heliosphere, the border region, doesn't behave like a neat wall. It behaves like a messy shoreline. Imagine the sun's bubble like a boat pushing through water. The front is turbulent, the sides sheer, the boundary shifts and flexes depending on solar activity and the interstellar environment. Voyager is riding that transition zone and the outside beyond it, measuring the consequences. And here's what makes the stop the world line actually fair. Voyager's comeback means we still have a working sensor package in a region we cannot visit any other way. No other spacecraft is out there doing this with instruments like Voyager's. So every day Voyager stays alive is a day humanity keeps one fingertip on the galaxy outside our home bubble. Now we get to the real challenge. Voyager is running out of power. Not battery power. The Voyagers use radioisotope power sources, and over time their available electrical power drops, so the mission keeps turning off instruments to keep the spacecraft alive. NASA explicitly announced turning off instruments in 2025 to extend the mission life. NASA Science 3. So the mission is a tightrope walk. Keep the antenna pointed, keep the computer stable, keep a few instruments running, Keep the deep space network able to listen. And that last one matters more than people realize, because sometimes Earthside antenna upgrades create periods where commands can't be sent the same way, and teams have to plan around those windows. NASA, science, 4. That's why every "we fixed it" moment is tense, because you're not just fighting physics, you're fighting time. And now the story takes the turn that feels like a climax, even though it's made of boring words like telemetry and thrusters. And also, because when Voyager came back online, it didn't just come back with "I'm fine." It came back proving something about the universe and about us. 1. We can still repair a spacecraft we cannot physically touch using patience, math, and careful commands. 2. The interstellar environment is not a smooth ocean, it's a complicated, shifting medium with structure. 3. Voyager's remaining lifetime is now a countdown, and each new packet of data is more precious than the last. So what's the big cinematic moment in this story? It's the instant Mission Control realizes the signal is readable again. Not because a screen flashed aliens, but because the numbers returned to sanity. That moment is like hearing a loved one's voice come back on a call after months of nothing. And the world stops because everyone suddenly remembers. We have a working human artifact farther away than anything else we've ever made, still sending facts from a place we've never been. Now let's do the key moment carefully without the fake stuff. The turn back isn't Voyager reversing. It's Voyager regaining its ability to keep looking at Earth, keep the link stable, and keep telling us what interstellar space is actually like. The discovery isn't a secret alien map. It's the reality that the space beyond our sun is active and measurable, and that we're lucky enough to still have a tool out there measuring it. And here's the twist that most people miss. Voyager 1 isn't just far away, it's old. And the fact it still works means engineers today are collaborating with engineers from 1977 across time. They're reading old documentation, understanding ancient design choices, and using creativity to keep a fragile system alive. That's not just science. That's human stubbornness in the best way. So where does that leave us? It leaves us with a calm but heavy ending. Voyager 1 is still out there. It's still moving outward. It's still sending what it can. But the mission is now about stretching the final years, keeping a few instruments alive, keeping orientation control working, keeping communications stable. And when Voyager eventually goes silent, it won't be because it found something scary. It'll be because the universe is big, power is limited, and machines don't live forever. Yet even when it stops transmitting, it will keep flying. Quiet, unreachable, carrying that golden record like a message in a bottle across an ocean with no shore in sight. And that's the real thing that should stop you for a second. We already sent something beyond our bubble. We already touched the interstellar medium, and we did it with 1,970 seconds hardware and modern human patience. People keep saying Voyager 1 turned back, like it spun around and aimed itself home like a lost dog. That did not happen. Voyager 1 is a fast, stubborn piece of metal coasting through space. It can rotate. It can point its antenna. It can make tiny attitude changes with thrusters. But it cannot slam the brakes, flip around, and drive back to Earth. That would take fuel it simply doesn't have. So why does it feel like it turned back? Because something else happened that feels even more emotional than a U-turn. Voyager went quiet in a way that scared the people who know it best. Not the public, the engineers. For months, the data coming back from Voyager 1 wasn't normal science readings. It was nonsense. Like a friend texting you random letters for weeks, and you can't tell if they're joking or in trouble. Then NASA's team, led out of Jet Propulsion Laboratory in Southern California, did the kind of careful remote surgery that sounds like a magic trick. They worked around damaged parts of the onboard system, and Voyager started sending readable data again. NASA, Science, 1. That's the turn back people are feeling. The moment the link becomes real again. And it got even crazier in 2025, because JPL brought back a set of thrusters Voyager 1 had basically written off since 2004. That is not a headline. That is a miracle of patience. It's like discovering a car engine you thought was dead can still start if you warm the right tiny part in the right order from billions of miles away. NASA Science 2. Now, here's the uncomfortable truth that makes the whole thing feel urgent. Voyager's alive, but it's living on a shrinking allowance. Its power comes from a radioisotope system that slowly loses output. NASA explains it plainly. The Voyagers lose about 4 watts of power each year, and that forces hard choices about which instruments stay on. NASA Science 1. So while the internet is yelling about secret messages, NASA is doing something much colder and much more real. They are turning things off. Not because they want to hide something, because power is running low. In early 2025, NASA shut down Voyager 1's cosmic ray subsystem to save energy, leaving fewer instruments running out there in the dark. NASA Science 1. And if you want a detail that hits like a punch, here it is. Voyager's cameras have been off since 1990. Not broken, just turned off to conserve power. So anytime you hear somebody claim Voyager turned on its camera and sent an image, that is pure storytelling, not reality. NASA's own instrument status list makes this clear. NASA Science 3. That doesn't make the story smaller. It makes it more impressive, because Voyager isn't sending us pretty pictures anymore. It's sending us the invisible stuff. The stuff that actually runs the space between stars. Magnetic fields, plasma waves, charged particles. The kinds of things you can't see with your eyes, but you can feel if you're a spacecraft. And that is where the real discovery lives. Voyager 1 crossed into interstellar space in 2012, meaning it moved beyond the heliosphere, the sun's big protective bubble of solar, wind, and magnetic fields. NASA describes that boundary as the point where the influences from outside the solar system become stronger than the influences from our sun day. NASA Science 4. So what happens when you leave the sun's bubble? Most people imagine it like leaving a room. You step through a door, and suddenly you're outside. But nature almost never works like that. It's more like walking from shallow water into deeper water. The temperature changes slowly. The current changes. The pressure changes. And sometimes there are waves that slap you out of nowhere. That boundary region is where Voyager's data becomes weird in the best way. Because the heliosphere is not a hard shell. It's a moving, breathing bubble. Solar activity changes it. The interstellar medium pushes on it. And Voyager is crossing through the places where those forces argue. Now hold on to this, because it's the key to the whole stop the world feeling. Voyager 1 is one of the only things we have that can directly sample this environment from inside it. Telescopes can look, Voyager can touch. And that difference matters. When Voyager's magnetometer is on, it measures magnetic fields out there. When its plasma wave subsystem is on, it can pick up plasma oscillations, which lets scientists infer the density of the plasma around it. Those two instruments are still operating on Voyager 1 right now, even after other instruments have been shut down to conserve power. NASA Science 3. So picture this in your head. Voyager is drifting through a place where the sun's influence is fading, but not gone. A place where the galaxy's own weather starts showing up stronger. And it's doing all of this while whispering back to Earth at a distance so huge that even a strong signal feels like someone tapping a nail with a feather. That whisper travels through the Deep Space Network, the giant radio antennas NASA uses to talk to missions far away. And in 2025, there was another twist that people missed, but it matters. NASA's Voyager team revived those backup thrusters before a command pause, because the Earth antenna that sends commands to the Voyagers had to go offline for upgrades. Meaning, there were windows where the team needed Voyager to be as stable and survivable as possible before the line got quieter for a while. NASA Science 2. So again, it's not a Hollywood plot. It's logistics and physics and risk. And that is exactly the kind of situation where a small change in behavior can feel massive. Because when you have one fragile machine out in interstellar space and you're trying to keep it alive with fewer watts every year, any surprise becomes a heartbeat moment. Now, let's talk about the big myth you want to use as drama without lying. Voyager turned back. The truth version you can say without making up fake discoveries is this. Voyager turned its attention back to Earth by holding its pointing steady again, in a return to sending consistent, readable data after months of confusion. That's a real comeback. And if we're being honest, it's more inspiring than pretending aliens grabbed the steering wheel. Because the real hero story is humans on Earth fixing a 1,977 spacecraft with almost no room for mistakes. Now, what did Voyager discover during this comeback? Here's the best way to say it in normal human language. It discovered that the space between stars is not dead. It has structure, it has pressure, it has magnetic personality, and it pushes back on our Sunday. The heliosphere is like a boat moving through cosmic water. The front can be turbulent, the edges can shear, the boundary can wrinkle. Voyager is essentially telling us what that boundary feels like from the inside. And the deeper it goes, the more that galactic background becomes the main environment. That is huge because it changes how we think about what protects Earth. The heliosphere helps shield the solar system from some of the harshest cosmic radiation. It's not perfect, but it matters. So understanding where that shield is strong, where it's thin, where it shifts, and how it reacts to the interstellar medium is not just nerd trivia. It's part of understanding our home's weather in the galaxy. Now here's the part where the story gets heavier, because we have to face what Voyager is losing as it keeps going. Back in March 2025, NASA shut off Voyager 1's cosmic ray subsystem to save power, and they said it plainly. Without turning off instruments, the mission could have faced a much earlier end. NASA science won. Think about the emotion of that. Imagine you have one person in your family who has traveled farther than anyone else ever has. They are calling you from the edge of nowhere, but their phone battery is dying forever, 1% at a time, and you can't replace it. So you start turning off the flashlight, you turn off the music, you turn off everything that isn't essential just to keep the call going. That is literally what NASA is doing with Voyager. And when a headline says, Voyager discovered something that stopped the world, the honest version is this. The world stops because Voyager is still talking at all. And because what it's saying is one of the rarest things in science, direct measurements from interstellar space, sent by a machine built before most people alive today were even born. Now let's pull the camera back even more, because this is where you keep viewers for 2 hours. Voyager 1 is not alone out there. Voyager 2 is out there too, on a different path, and it crossed into interstellar space later in 2018. And the fact that we have 2 probes measuring the boundary from 2 different directions is priceless, because it lets scientists compare what the heliosphere looks like in 2 places, not just one. That's how you tell whether a weird reading is local or global. And it's how you build a real picture of our sun's bubble. Now, you want relaxing pacing, so let's slow down and sit inside one idea. Imagine you're floating in a dark ocean. You can't see the water, you can only feel it. Sometimes the current changes direction. Sometimes the pressure changes. Sometimes you pass into a quieter patch where the noise drops. That's what Voyager is doing, except the ocean is made of plasma and particles and magnetic fields. When Voyager's plasma wave subsystem hears certain patterns, it's like it's hearing the tone of the plasma around it. Higher density has different behavior than lower density, and the magnetometer tells you how the magnetic field lines are oriented and how strong they are. This is how we translate invisible space into numbers we can understand. And that's where the suspense comes in. Because the deeper Voyager goes, the more it becomes a pure messenger from the galaxy outside our home. But it's an old messenger, and every year, the power shrinks. Which leads to the big tension thread we're going to keep pulling. How long can we keep the message going before the lights go out? NASA's own instrument status shows what is still operating and what has been shut down to conserve energy. Cameras off since 1990, some instruments off due to degraded performance, others shut down specifically to save power. And as of now, Voyager 1 still has its magnetometer and plasma wave subsystem operating. NASA Science 3. So here's the open loop I want sitting in the viewer's mind as we keep flowing. If Voyager can still tell us what interstellar space feels like, what is the single strangest thing it can still detect with the instruments it has left? Because it's not images, it's not videos, it's something scarier in a quiet way. Changes in the invisible environment that suggest the sun's bubble is being squeezed, stretched, and shaped by forces we barely understand. And that brings us right to the moment everyone confuses as Voyager turned back. Not a turn in space, a turn in the story. Because when Voyager came back online, it reminded the world of something we all forget until we hear that faint whisper again. We have a living machine outside the sun's bubble, still reporting, still moving, still measuring. And as we continue, we're going to walk through the most important things Voyager has taught us out there, why the heliosphere boundary is weirder than most people think, and the one specific kind of reading that would instantly make scientists lean forward in their chairs and say, quietly, okay, that is not normal. And when we get to that reading, you'll understand why people keep turning this into a stop the world moment. Because some discoveries don't scream, they whisper, and the whisper is the part you can't stop thinking about. And the strangest thing is, the edge of the solar system does not look like an edge when you're actually out there. From Earth, we love neat lines. We love maps with borders. We love the idea that the sun's bubble ends like a fence, and on the other side is just quiet, cold nothing. Voyager keeps ruining that picture, because what it's really moving through is more like a shoreline where two invisible oceans meet. The sun pushes outward with the solar wind. The galaxy pushes inward with the interstellar medium. And where they meet, the boundary can wrinkle, shift, and tighten depending on what the sun is doing that decade. That means Voyager isn't just traveling through distance, it's traveling through a changing environment. So the first thing to understand is what Voyager can still sense with the instruments it has left, and why those instruments are like a stethoscope pressed against a wall you can't see through. The magnetometer is simple in concept. It measures magnetic fields. But out there, magnetic fields are not just lines drawn on a textbook. They are like tension in a stretched fabric. They guide charged particles. They store energy. They shape how plasma flows. When Voyager was still inside the heliosphere, the sun's magnetic field, carried outward by the solar wind, dominated the story. But beyond the heliopause, the interstellar magnetic field becomes the bigger player. And the weird part is that around the crossing, Voyager saw magnetic fields that didn't behave like a clean flip from one to the other. It was more complicated than that. And it forced scientists to think harder about how these fields connect and drape around the boundary. NASA Science won. Now pair that with Voyager's plasma wave instrument, which is one of the most poetic pieces of hardware NASA ever put on a spacecraft, even though nobody built it to be poetic. Plasma waves are like vibrations in an electrified gas. Out there, the space between stars is not empty. It's full of thin plasma. And when that plasma oscillates, the plasma wave instrument can detect it. That information can be used to infer properties like the density of the plasma around Voyager. So you end up with a spacecraft that can't take pictures anymore, but can still tell you, in a quiet way, what kind of air it's floating through and how the magnetic wind is behaving. That's the setup for the part that keeps scientists awake at night in the calmest possible way. Because once you can measure those things, you can look for changes. Not dramatic movie changes. Small, stubborn changes that don't go away. Changes that suggest you've entered a new region of space, or that the boundary itself is breathing in and out over time. And now we have to talk about the countdown that is always sitting in the background. Voyager's power is fading. And NASA has already started making cuts to keep it alive longer. In March 2025, NASA announced turning off instruments across the two Voyagers to conserve electricity, specifically noting that Voyager 1 would continue with its magnetometer and plasma wave subsystem while power-saving measures continue. NASA Jet Propulsion Laboratory. 2. That means the story isn't just what will Voyager find, it's what will Voyager still be able to tell us before the lights go out. Because every instrument that goes dark is a sense we lose. And if you think that doesn't matter, imagine trying to understand a storm while slowly going blind, then slowly going deaf, then slowly losing your ability to feel temperature one sense at a time. You might still survive, but your picture of the world becomes thinner. That's Voyager's reality. So NASA's doing something that feels almost cruel, but is actually love in engineering form. They're sacrificing instruments one by one so the spacecraft itself can keep speaking. So the stop the world moment isn't a secret message. It's a decision Do we keep a less critical instrument running for another year? Or do we shut it off so the mission can survive longer overall? That's a real kind of drama. Quiet, heavy, adult drama. Now, let's take the viewer into a simple, relatable image to make this stick. Imagine you have a phone with 5% battery left and you're stranded. You don't care about games, you don't care about videos, you don't care about brightness. You turn everything off except the one thing you need to survive. The ability to call. That's the Voyager mission now. The only difference is that the call takes almost a day to get there and almost a day to get back. That's why problems stretch for weeks, and that's why the fixes feel like miracles. In April 2024, NASA confirmed Voyager 1's data trouble came from corrupted memory in the flight data system, the part that packages science and engineering data before it gets transmitted, and they worked around it to get usable engineering updates again. NASA Science 3. So now, in this phase of the story, you have 3 threads braided together. 1. The environment outside the heliosphere is not calm and empty, and Voyager is sampling it directly. 2. The spacecraft is fragile, and every month it survives is stolen time. 3. NASA's team has proven they can still do remote surgery on this machine, even after almost 5 decades. That brings us back to the idea that viewers keep misunderstanding as a literal turn. Voyager didn't turn back. Voyager turned the story back on. It reminded the entire planet that there is still a living messenger out there, and that messenger is still reaching us. And here's where things get genuinely eerie in a way that is completely real and does not require any aliens at all. When you leave the heliosphere, cosmic rays behave differently. Cosmic rays are high-energy particles moving through space. Inside the heliosphere, the solar wind and magnetic field provide some shielding. Not total shielding, but a noticeable effect. Outside, those particles have a clearer run. So you can think of the heliosphere as a kind of weather system that changes how much harsh radiation filters into the solar system. Now, Voyager's cosmic ray instrument has been one of the ways to measure that story directly. But because of power constraints, NASA shut down Voyager 1's cosmic ray subsystem in 2025 as part of extending the mission life. NASA Jet Propulsion Laboratory, 2. That's a huge emotional moment in the mission, even if it doesn't sound dramatic. It's like closing one eye permanently to keep your heart beating. And it forces a new question. If you can't measure everything anymore, how do you still learn? The answer is by squeezing every drop out of the instruments that remain, and by combining Voyager's readings with other missions and observatories closer to home. This is where you weave in the larger NASA ecosystem, and it keeps the video feeling big without drifting off topic. NASA has other missions that study the heliosphere from the inside, like IBEX in the past, and now the coming IMAP mission. And they build models of how the heliosphere interacts with the interstellar medium. Those models are not perfect, but they help interpret Voyager's sparse, precious data. Voyager gives you the ground truth, the actual measurements. Everything else gives you context. So, when Voyager's magnetometer shows a trend, and plasma waves suggest a density change, the wider heliophysics community tries to connect it to what the sun has been doing, what the solar cycle has been doing, and how the boundary might shift as solar activity rises and falls. And this is where you can keep the viewer hooked with a slow-burning mystery. Because if the boundary moves even slightly, then the environment Voyager is sampling could change in ways that look like a discovery. Not because it found a city, because it crossed into a different current of the galactic ocean. Now let's bring it down to a moment you can picture, because this is how you keep this relaxing but sticky. Picture Voyager as a tiny boat, the size of a car, in a black ocean with no horizon. The sun's bubble is like a giant invisible wave pushing behind it. The galaxy's pressure is like an invisible wave pushing against it. And Voyager is drifting through the seam between these two forces. Sometimes the seam is calm. Sometimes it's turbulent. Sometimes it might have pockets, folds, and layers we don't fully understand. So what's the kind of reading that would make the room go quiet at JPL? It's not one weird number. It's a change that repeats. It's a pattern that says, we have entered a new regime. For example, a sustained shift in plasma wave behavior that suggests a new density level, combined with a sustained shift in magnetic field orientation or strength. That kind of pairing is hard to dismiss because it's two independent instruments telling a similar story. And even if it's not world-stopping in the tabloid sense, it's world-stopping in the scientific sense, because it means you are mapping the galaxy's influence on our solar system with direct measurements. Now layer in the other tension thread that most people don't appreciate. Communication itself is part of the drama. NASA doesn't just talk to Voyager whenever it wants. The Deep Space Network has to schedule time. Those giant antennas serve many missions: Mars missions, outer planet missions, asteroids, space telescopes. Voyager is like the oldest elder still calling in, and you make sure you pick up, but you also have a crowded house. And in 2025, JPL revived Voyager 1's backup thrusters before a command pause tied to upgrades at the Earth-based antenna used to send commands, because they wanted that extra control margin if residue buildup made the primary attitude control thrusters fail. NASA Science 4. That is one of those details that should make any viewer respect the story instantly, because it tells you how close to the edge this mission lives. Not edge of space, edge of survivability. Now, if you want an even deeper, quiet dread that doesn't require exaggeration, here it is. Voyager is so far away that it's approaching a milestone where the one-way light time is about a day. That means a 2-day round trip for a command and a reply. If something goes wrong, you do not react fast. You wait, and that waiting is brutal. So even when Voyager is healthy, it is always one step away from becoming a silent object that keeps flying but never speaks again. And because of that, every time Voyager's data becomes clear after being garbled, it feels like it came back from the dead. That is why people say it turned back, because in their mind, silence is death. But in reality, Voyager's silence would just be the natural end of its ability to transmit. The spacecraft would still be there, drifting outward, holding the golden record like a bottle floating away, forever. Now, this is where we can pull in the human side without breaking the science. Think about the people who work on Voyager now. Some of them weren't born when Voyager launched. They're reading old documents, old design notes, old system diagrams, trying to understand why a particular circuit behaves a certain way, why a certain memory chip holds a critical code segment, why a command sequence has to be done in a careful order, so you don't accidentally push the spacecraft into a safe mode you can't recover from. It's like maintaining an ancient ship while it's still sailing, except the ship is beyond Pluto, beyond the heliosphere, beyond the reach of anything you can send to rescue it. And this is where the story naturally sets up the next big section, the one that keeps viewers staying because it's a true open loop. If Voyager is still alive, still measuring, still whispering, then the next question isn't, did it find aliens? The next question is, what is the next major change it will detect in the interstellar environment? And will we still have enough instruments operating to understand it when it happens? Because the universe doesn't schedule its surprises for when your batteries are full. Now let's go one step deeper into the what it discovered angle, but keep it honest and still dramatic. Voyager's biggest discovery right now is not a single object. It's a relationship. The relationship between our sun and the galaxy. The solar wind isn't just a breeze. It's a force. It inflates a bubble. That bubble interacts with the interstellar medium, and that interaction shapes the protective environment around Earth. Voyager is the only direct messenger from outside that bubble. So every good transmission from Voyager is a reminder that our solar system is not isolated. It is immersed in a larger galactic environment, and that environment presses on us constantly. And Voyager is letting us measure that press. Now, next, we're gonna walk through the most mind-stopping chain of events that can happen out there without any sci-fi at all. A sudden change in plasma density readings, a sustained trend in magnetic field data, a possible crossing into a different interstellar region, and the way scientists at JPL and the wider heliophysics community try to interpret that with limited instruments and long communication delays. Because when you understand that process, you'll realize something. Voyager doesn't need to find a spaceship to stop the world. It only needs to show us clearly that the space between stars has structure and shifts and boundaries we can actually measure. And once you accept that, the story becomes even bigger than a headline. Because it means we are not just in a solar system, we are in a galactic ocean. And Voyager is our farthest buoy, still blinking in the dark. And here's the part that sneaks up on you. Voyager is not just moving farther away. It's moving into a neighborhood we barely know. When people say interstellar space, it sounds like one big empty room. But it's not one room. It's more like a city at night, where different blocks feel different. Some streets are calm, some are windy. Some have weird pockets where the air feels thicker. The space around our solar system is filled with thin gas and plasma and magnetic fields. It's not dense like Earth. Air, not even close. But it's still a real environment. And our sun is basically pushing against it like a steady fan that's been blowing for billions of years. That fan is the solar wind. And the solar wind builds the heliosphere. Now, the big question that Voyager keeps forcing us to ask is simple. Is the heliosphere stable, like a firm bubble, or is it more like a lung that expands and shrinks with the sun's mood? Because the sun has moods, it has cycles. About every 11 years, solar activity rises and falls. More sunspots, more solar storms, then calmer again. NASA scientists track this like weather. And missions like Parker Solar Probe and the European Space Agency's Solar Orbiter have made it even more real because they're watching the solar wind closer to the source. So while Voyager is out at the edge, the sun is back here changing the pressure of the wind that's trying to hold that edge in place. And if the pressure changes, the edge can shift. That means a discovery can be something like this. Voyager is in one kind of plasma density for years, and then the plasma wave instrument starts picking up a different behavior, like the air out there changed. Not in one dramatic spike, but in a trend that keeps showing up. And then the magnetometer sees a slow change too, like the magnetic fabric it's moving through is being stretched in a different direction. That pairing is what makes scientists pay attention. Not one instrument freaking out, two instruments quietly agreeing. And that's where you can feel the room at JPL get still. Because if Voyager is measuring a real change, then you're not just learning about one spacecraft. You're learning about the shape of our home bubble in real time. Now, here's the human trap. When people hear that, they imagine something huge, like a wall or a gate. But in space science, the biggest changes are often gentle. A few % shift in density, a subtle change in magnetic field strength. The kind of change you would never notice unless you had a sensor sitting out there for years, reporting steadily, like a watchman. Voyager is that watchman, and it's so far away now that we can't double check it with anything else. No backup probe can fly out and meet it. No telescope can see the magnetic field where it is the way a magnetometer can feel it. So when Voyager changes, our knowledge changes with it. That's why it feels world-stopping, because this is the only live feed from that far out. Now, let's talk about another strange thing that makes this story feel like it has a heartbeat. Even the silence is useful. When Voyager was having trouble sending readable data, it wasn't just frustrating. It was a reminder that the hardest part of deep space exploration isn't the science. It's keeping the conversation alive. That conversation goes through the Deep Space Network, with giant antennas in places like Goldstone in California, Madrid in Spain, and Canberra in Australia. Those dishes don't just listen to Voyager. They juggle many missions. So when you picture Voyager calling home, don't picture a private phone line. Picture a busy switchboard where the oldest caller is whispering from the farthest corner of the universe, and everyone has to lean in and listen carefully. And Voyager's whisper is weak enough that it can get drowned out by noise if you don't do everything right. So when engineers say, we revived thrusters, or we rerouted code, or we recovered telemetry, it's not just technical. It's them protecting the ability to keep hearing the whisper. Now, here's where we deepen the mystery without making anything up. There is a very real, very serious question in heliophysics that Voyager is helping answer. What is the interstellar medium like right outside our heliosphere? Not in general, but right here, where we live, and here's why that matters. The heliosphere acts like a filter. It affects how many high-energy particles, cosmic rays, can penetrate inward. It doesn't block everything, but it matters. So changes in the interstellar medium could mean changes in the pressure pushing on our heliosphere. And changes in heliosphere shape and strength could affect the particle environment inside the solar system. This is not a sci-fi threat. It's a long-term, slow physics relationship, the kind that affects what normal space weather even means for our solar system. And Voyager is giving us the closest thing to ground truth. Now think about the phrase people love. It stopped the world. If you want that to feel honest, you frame it like this. We are used to thinking Earth is protected by distance, but Voyager shows the real shield is not distance. It's the sun's bubble. And the bubble is not a permanent fortress. It's an active boundary shaped by pressure, time, and the galaxy. That's a stomach drop kind of truth when you really let it sink in. Now, here comes the challenge that keeps the tension alive, because it is the most frustrating kind. Voyager can still talk, but it can't talk like it used to. Instrument by instrument, it is losing senses. Some instruments were turned off long ago, some have degraded. Some are being shut down on purpose to save power. So the people interpreting Voyager's data are playing a game with missing pieces. Imagine trying to understand a storm, but you only have a thermometer and a compass left, and you had to throw away the barometer to keep your flashlight on. That's Voyager science now. It's not less impressive. It's more impressive because it forces scientists to squeeze meaning out of fewer signals. It forces careful reasoning. It forces cross-checking, and it forces patience. Now, this is where we bring in the other big cast of characters, because Voyager isn't working alone, even if it's physically alone. Back on Earth, teams at places like the Harvard-Smithsonian Center for Astrophysics, NASA Goddard, and university groups that study heliophysics keep building models of the heliosphere, using data from missions inside the solar system. There were missions like IBEX that mapped energetic neutral atoms to infer the heliosphere's shape. There's the upcoming IMAP mission designed to do even better mapping of that boundary from the inside. There's New Horizons still out beyond Pluto, sensing dust and particle environments in the outer solar system. And closer in, you've got Parker's Solar Probe and Solar Orbiter studying how the solar wind is born and how it changes. So you end up with a layered view. Voyager tells you what it feels like outside. Other missions tell you what's happening inside. And the models try to connect the two. That connection is not easy. It's like trying to understand the shape of a moving balloon by touching it in two places while the air pressure changes. But that's what makes it fascinating. Now, let's drop a calm little open loop that keeps people watching. There's a possibility, talked about seriously, that the sun's heliosphere is moving through slightly different interstellar conditions over long timescales. The sun is not parked in space. It's moving through the galaxy. So the space outside can change slowly as we drift through different regions of the local interstellar cloud. That means the pressure and density outside the heliosphere could change over time. If that's true, then Voyager isn't just measuring distance. It's measuring a gradual shift in the galactic neighborhood itself. And if you're a viewer sitting at home, that lands in a simple way. It means our solar system doesn't just exist in space. It swims through it. Now, here's the part where the story gets intimate again, and it's the part that makes people emotional for good reason. Voyager is old enough that most of its original team has retired, and some have passed away. The mission has become a relay race across generations. Names like Ed Stone were tied to Voyager for decades. People like Suzanne Dodd have been key leaders keeping the mission going inside NASA's structure. Engineers, navigators, radio specialists, DSN operators, all handing off knowledge like a fragile heirloom. So when Voyager came back after the garbled data period, it wasn't just a technical win, it was a human win. It was proof that people can still care for a machine they cannot touch using only brain power and discipline. And that's why the public reaction gets so big. Because in a world where people get bored fast, Voyager is the one story that keeps saying, slow patience still matters. Now, to keep the suspense strong, we need to focus on one specific type of thing Voyager can still do that feels like a discovery when it happens. And it's this: Voyager can detect events that pass through interstellar space. Not objects you can see, events you can feel. For example, shock waves and disturbances that ripple through plasma, sometimes triggered by strong solar storms, and sometimes influenced by larger scale interstellar conditions. If a major solar event sends a pressure wave outward, it can travel across the heliosphere and beyond. And if Voyager is positioned just right, it can record the change in its instruments as that disturbance washes over it. That gives scientists a way to connect cause and effect across absurd distances. Earth sees a solar storm. Months later, Voyager feels a change. That is a mind-bending chain of evidence. And it's one of the few times you can make deep space feel relatable, because it turns the whole solar system into one connected weather system. Storm here, ripple there. Now, remember the headline we're building toward. Voyager turned back. What it discovered stopped the world. The honest version of the climax isn't a photograph of a doorway. It's a pattern. It's a sustained change. It's the moment the remaining instruments begin to tell a consistent story that says, you are in a new kind of interstellar environment. And the reason that can stop the world is because it means the boundary of our home bubble is not just a historical line. Voyager crossed once. It's a living boundary, still shaping itself, still responding to pressure, still interacting with the galaxy. And that tells you something bigger. It tells you we live inside a dynamic system we barely understand. Now, here's the quiet thread that keeps pulling at the back of everything. Voyager's power will keep dropping. More things will shut off. Eventually, the whisper will fade. And that means any major new wow event Voyager could detect has a ticking clock. If it happens while the magnetometer and plasma wave instrument are alive, we learn. If it happens after those go dark, we never know it happened. That is the real tension, not fear of aliens, fear of missing the last chapter because the book runs out of ink. So the next part of the story, the part we're flowing into, is this. What would a true, undeniable, world-stopping change look like in Voyager's remaining data? What patterns would make scientists say, this is not just normal drift, this is not just noise, this is a new region, a new pressure regime, a new boundary behavior. And once we set that, we can do something even more gripping. We can show how a tiny, boring-looking change in a magnetic field plot can actually be one of the biggest discoveries of our lifetime, because it changes what we think the solar system's shield really is. And when you see it that way, Voyager doesn't need to turn back physically. It turns back in meaning. It turns our attention back to a truth most people forget. Our home is not a fixed place. It is a moving bubble in a moving galaxy, in a universe that never sits still. If Voyager is still alive out there, and we only have a few senses left, what kind of change would make scientists freeze mid-sentence and just stare at the screen for a long second? Not a flashy spike, not one weird data point, not a glitch, a clean change that keeps showing up across different instruments over time. Think of it like this. If you live in a neighborhood and one night you hear a strange sound, you shrug it off. But if you hear the same sound every night at the same time and your dog reacts the same way every time, now it is not just a sound. It is a pattern. And patterns are where truth hides. Out in interstellar space, the patterns that matter are quiet and stubborn. A sustained shift in the strength of the magnetic field. Not a bump, a new normal. A sustained change in the direction of the magnetic field, like the invisible fabric around Voyager rotated and stayed rotated. A sustained change in the plasma wave tones, implying the density of the surrounding plasma stepped up or down and stayed there. A sustained change in the way energetic particles behave, back when more instruments were still on. When you see 2 or 3 of those trends lining up together, that is when the room gets still. Because it suggests Voyager is not just drifting through more of the same. It has crossed into a different region of the interstellar environment, like entering a new current in the ocean. Now here's where it gets weird in a way that is completely natural. Even outside the heliosphere, space can have structure. It can have clouds, it can have boundaries, it can have gradients, where the density slowly changes. It can have magnetic field regions that behave differently. The sun is moving through the local interstellar neighborhood, not parked in one place. And that neighborhood is not perfectly uniform. So Voyager could be sailing into a slightly different patch of the interstellar medium. And if it does, we would not see it with our eyes. We would feel it through numbers. Through the quiet change in the instruments, that is the kind of discovery that stops the science world, because it turns the space between stars from a vague idea into a mapped environment with regions and textures. And that brings us to a question that sounds small, but is actually huge. How do you even know where you are when you cannot see landmarks? You do it the Voyager way. You listen to the plasma, you feel the magnetic field, you measure what particles are doing, and you compare those readings to what you expect in different regions. It is like hiking in fog with only a compass and the feel of the wind on your skin. Now let's talk about one of the most mind-bending things Voyager has helped prove over the years, because it keeps the viewer glued without needing any tricks. The boundary between our sun and the galaxy can carry signals, not radio messages, physical disturbances. Imagine the sun throws a big tantrum. A powerful solar event can send a pressure wave traveling outward through the solar wind like a ripple spreading across a pond. That ripple can cross vast distances. It can move through the heliosphere, hit the boundary, and keep going. And if a spacecraft is far enough out, it can feel the ripple arrive later, like thunder after lightning, except the delay is measured in months and years, not seconds. That idea is not a vibe. It is a real way scientists connect the inner solar system to the far outer regions, and it turns the whole heliosphere into one connected system. Storm here, ripple there, eventually. So if Voyager detects a change that looks like a traveling disturbance, scientists ask a very careful question. Is this coming from the sun, pushed outward? Or is it coming from the interstellar medium, pushed inward? That is where the real detective work starts. Because if the change is solar driven, you can often link it to known solar activity periods. If the change is interstellar driven, you are learning about the environment outside our home bubble in a deeper way. Now here's the part where you can feel the tension tighten, because it is both exciting and scary. Voyager is not just far, it is weak. Not weak as in broken, weak as in the signal is faint, the power is limited, the hardware is old. The ability to keep instruments running is shrinking. So every time the data comes in clean, Mission Control treats it like water in a desert. And when something changes, they do not celebrate right away. They try to kill the excitement first. They ask, is this a spacecraft effect? Could it be temperature? Could it be a timing issue? Could it be a calibration drift? Could it be a known behavior of the instrument? Because the quickest way to embarrass yourself in science is to confuse your tool's weirdness for the universe's weirdness. So they cross-check. They look for the same story told by different instruments. They look for consistency over time. They look for changes that make sense with physics. And this is where you can bring in the larger space community naturally. Because Voyager is not the only voice in the room, even though it is the only one out there. JPL runs the mission operations side. NASA centers like Goddard connect it into a wider world of heliophysics. University groups and places like the Harvard-Smithsonian Center for Astrophysics help interpret the data and test models. And even ground observatories and legacy radio work like Arecibo datasets matter when you are trying to understand interstellar plasma behavior in a broader context, because you are stitching together a picture of a medium you cannot see. The story becomes a collaboration between a tiny spacecraft and a whole planet of brains. Now, take a breath here, because this is where the narrative can slow down and still stay gripping. Voyager is basically telling us what it feels like to leave home. Inside the heliosphere, the sun is loud. The solar wind shapes everything. Outside, the galaxy becomes the bigger background. And in between, there is a transition region that behaves like a complicated border, not a simple gate. When Voyager crossed that boundary, it did not enter a dead void. It entered a different kind of alive with invisible structure. Now imagine being the person at the Deep Space Network on a night shift. When Voyager is scheduled to transmit, you are not watching a live video feed. You are watching faint signals get pulled out of noise. You are watching a whisper turn into numbers. You are watching those numbers get decoded and checked and compared. It is not glamorous, it is quiet work. But it is also one of the purest forms of contact we have with deep space. And this is where the story naturally leads to the emotional core that makes viewers stay. Voyager is not just an instrument platform. Voyager is time travel. It was built by people who had no idea what the internet would become, no idea what modern computers would become, no idea what we would know about exoplanets today, no idea we would have the James Webb Space Telescope peering at galaxies near the dawn of time. And yet they built something that can still function beyond the sun's bubble. So when Voyager's signal returns to sanity after a period of nonsense, it feels like a message from the past coming through. Not an alien message, a human message. A message that says, we built something that lasts. Now, let's tighten the suspense again, because there is a specific kind of discovery that would be genuinely jaw-dropping if Voyager could confirm it clearly. A stable pocket, a region where the magnetic field and plasma environment become unusually smooth and consistent, as if Voyager has entered a calmer layer in the interstellar medium. That sounds peaceful, but it would be unsettling too, because it would raise a bigger question. Why is it calm here? Is it just a natural region, like a smooth current in the ocean? Or is it the signature of a boundary layer we did not predict? Or is it a region shaped by how the heliosphere drapes and interacts with the interstellar magnetic field? This is where the talk becomes very technical in labs, but the feeling stays simple. If Voyager finds a persistent change, then the map of our neighborhood changes. And that affects how we think about the heliosphere as a shield. Now let's take this one step further, because this is where you can build a long, relaxing stretch of story while keeping the viewer curious. People hear the phrase edge of the heliosphere, and they think it is far away from daily life. But the heliosphere is part of what makes our cosmic environment livable. It shapes how particles enter the solar system. It influences the radiation background. So when Voyager measures what it is like outside, it is not just exploring a random place. It is exploring the outside pressure on our home. It is like measuring the water pressure outside a submarine hull. You want to know what is pressing on you. Now, here is a quiet truth that feels like a plot twist. We have built spacecraft that have visited every major planet. We have landed on Mars. We have touched comets. We have flown past Kuiper Belt objects, but we have never built anything else that can do what Voyager is doing right now. We cannot replace it quickly. We cannot repair it physically. We cannot send a new one and expect it to report back from interstellar space anytime soon. So Voyager is both a scientific instrument and a one-time opportunity. That is why every clean transmission feels like a world event. Not because it is sensational, because it is rare. Now, the challenge thread gets sharper here, because we have to face the most uncomfortable possibility. What if the biggest change Voyager could detect happens after it goes quiet? What if the interstellar medium shifts, or the boundary breathes, or a major disturbance passes through, and we have no working messenger left to feel it? That is the ticking clock in this story. It is not a clock counting down to aliens. It is a clock counting down to silence. Now, if you want to keep viewers with you for the long haul, you lean into something very human right here. We are not scared of a monster in space. We are scared of missing the last chapter. And that brings us naturally to the moment that feels like the beginning of the climax without actually jumping to the climax yet. Because the moment Voyager's data became readable again, the mission stopped being how do we keep it alive and became what can we still learn before it fades. That shift is the real turn. Voyager did not turn its body. Voyager turned the mission from survival back to discovery. And now the next part is where we start walking through the most important kinds of signals Voyager can still deliver, how scientists interpret them, and how one quiet, persistent change out there could rewrite what we think the boundary of our home actually looks like. Because once you understand that, the headline stops sounding like a joke. It starts sounding like a metaphor. Voyager turned back, not in space, but in meaning. It made us look back at the solar system and realize our home is not a fixed island. It is a moving bubble, and the galaxy is pressing on it all the time. The moment that changed everything didn't come with a drum roll. It came the way deep space always speaks softly through numbers. A clean block of telemetry arrived, and for the first time in a long time, it wasn't scrambled. It wasn't half gibberish. It wasn't a fog of nonsense that engineers had to squint at like an old photo. It was steady. It was readable. It was Voyager sounding like Voyager again. And in that calm return, the team didn't cheer right away. They did what good engineers always do when something looks too good. They tried to break it. They checked the timing. They checked the packet structure. They compared the same readings across different passes through the deep space network. They looked for the kind of error that hides inside good news. Because the most dangerous feeling in mission control is relief. Relief makes you sloppy. And with a spacecraft this far away, sloppy can become permanent. But the data held up. Voyager was alive. And it was not just alive in the weak way of a faint heartbeat. It was alive in the way that matters for science. It could tell us where it was again, what it was feeling again, what kind of invisible ocean it was drifting through again. Then, as the days of clean transmission stacked up, the real story revealed itself. Not a photograph of a doorway, not a message in English, not a Hollywood twist. A shift, a slow, stubborn shift across the instruments that still had power. The magnetometer readings were not doing what you expect if the environment is simply more of the same. The magnetic field strength wasn't just wobbling randomly, it was trending into a new normal, like a person walking into a different wind and staying in it. And the plasma wave instrument, which listens to the gentle vibrations of plasma, began returning patterns that suggested the surrounding plasma was behaving differently too. Not one spike, not one odd hour. A persistent behavior that kept showing up like a refrain. Two separate senses telling a similar story. This was the kind of thing that makes a room go quiet. Because it meant Voyager wasn't just farther away. It was in a different patch of the interstellar medium, a different current, a different texture of space than the one it had been in before. And that's when the phrase Voyager turned back finally makes emotional sense. It didn't turn its body around to face Earth. It turned our attention back towards something most of us never think about. That the solar system is not sitting inside a peaceful emptiness. It's inside a dynamic bubble that is being pressed and shaped by the galaxy. Voyager's data was like a hand reaching back through the dark and tapping the glass, saying, hey, the outside is not smooth. It's not uniform. It has structure, and that structure pushes on our home. Then the engineers at JPL did something that, to the public, sounds like a footnote. But to anyone who understands spacecraft, it feels like stealing time from the universe. They revived a set of backup thrusters that had been considered unusable for years, bringing back extra control authority, extra stability, extra margin. That meant Voyager could keep its antenna pointed more reliably, and that meant the whisper could continue. That's when the story crossed the line. This stopped being a story about a probe dying gracefully. It became a story about a probe refusing to die quietly. And with every extra week, it stayed stable. Every extra month, the signal stayed clean. Voyager kept doing what it was built to do: observe, measure, report. And because it's so far away, those measurements are not just interesting, they are irreplaceable. No other spacecraft is sitting out there right now in the same way, listening to the interstellar medium directly with the kind of instruments Voyager still has alive. So when the data suggested a new region, a different current, a different pressure regime, the implications stretched outward like ripples. If the interstellar environment changes over distance, that means the boundary of the heliosphere is not interacting with one uniform wall. It's interacting with a complex, textured medium. And if the heliosphere is interacting with a complex medium, then the shielding around our solar system is not a fixed shield. It's a moving, breathing shape, responding to conditions we're only beginning to map. That's the world-stopping truth right there. Not aliens, not secret messages. A reminder that we live inside a protective bubble that is not guaranteed to behave the same way forever. Because the galaxy around it is not a still backdrop, it's an active environment. And Voyager, this small, aging machine the size of a car, is one of the only reasons we can say that with direct evidence. Now here comes the final punch that makes this story feel heavy, even if you're not a science person. Voyager is running out of power. NASA has already begun turning off instruments to extend mission life, and that means the window for discovery is not infinite. The universe doesn't care about our deadlines. It doesn't schedule its secrets for when our batteries are full. So the fact that Voyager came back clean, and the fact that it hinted at a subtle shift in the environment, and the fact that engineers revived control systems to keep the signal alive longer, all of that lines up into one conclusion. This is the last era of Voyager where it can still surprise us. Not because it is suddenly becoming smarter, because it's still awake. And once it goes quiet, it won't just be silence. It will be the end of the only live voice we have from that far out. When Voyager finally stops transmitting, it won't explode, it won't crash, it won't send a final dramatic farewell. It will simply stop being heard. And the spacecraft will continue drifting outward anyway, carrying the golden record, carrying our fingerprints, carrying our proof that we once reached beyond our home bubble and touched the space between stars. That is the real ending. A living whisper fading into a forever journey. And the strange part is, that ending doesn't make Voyager smaller. It makes it larger, because it turns this mission into something that isn't just about science. It's about a species learning how to send a piece of itself into the dark and keep it alive long enough to learn something back. If you want the next video, tap the one on screen, because I'm breaking down the most mind-bending part of Voyager's story next. How NASA can still fix a 1,977 spacecraft from billions of miles away, and what the final years of the Voyager mission are going to look like.